My name is Marinda Hall, and I'm your host here. I was here on Tuesday, yesterday, and I'm here today as well. A big welcome to you live here in Amsterdam, and also hello to you if you're looking at our recording, because all our sessions here in Theatre 2 are recorded, and we have a huge audience at the back of the camera who will be looking at us later. Also for you, all these sessions are available through the Intertraffic app, so if you need them, you can have a look if you've missed something. Today we had a session earlier about automatic incident detection, and now we also have a presentation on automatic incident detection, but on fire detection and deep learning. And today we have Erwin Blankaert from Teledyne Fleur to tell us all about this. May I have a round of applause for Erwin? Hey, Erwin. We made
Hello.
a joke. We made a joke that it feels like a bit like a rock star entrance, right?
Yeah, it does.
Yeah. Well, great you're here.
Thank you.
If we have any questions for you, should we do that at the end of the presentation? Would that work?
Yeah, I would prefer at
Yeah,
the end.
sure.
I think we will still have a little bit of time then.
Sure. I'll walk around with a microphone later on. Take it away, Erwin.
Okay, thank you very much. Hello, everybody. I'm very excited and honored to be here. My name is Erwin Blankaert. I'm a product manager at Teledyne Fleur ITS, Intelligent Transportation Systems. And today I'm going to talk to you about the next generation of automatic incident detection, using dual vision for effective fire detection and using dual vision for effective deep learning for automatic incident detection. So I can't help it, but every time I drive through a tunnel, I look at the ceiling. I look at the technology which is in place which makes tunnels safer. And last week I was driving through the Liefkenshoek tunnel in Antwerp, and I was thinking to myself, have tunnels become safer? So probably the most of you still remember the big tunnel fire in the Mont Blanc in 1999, where 39 people were killed. So after the investigations of this incident, they found out that the real killer was the smoke. The tunnel was filling with smoke and people were trapped by the smoke. Also, the smoke was blinding the CCTV cameras. So the tunnel operators couldn't see what's happening or couldn't see people inside the smoke. So they couldn't give the right directions to the fire or the rescue team. So if this exact incident would happen again today, would I have a better chance to survive? Well, the answer is not that easy, because a lot depends on what technology is behind the automatic incident detection, because it changed a lot over the years. In the 90s, the analog cameras were the standard in the market for automatic incident detection. And then after a few decennium, there was a market shift going from analog cameras to IP cameras. So IP cameras give a lot more resolution, a lot more details. So this gives an extra boost to the automatic incident detection system. Then in 2016, Fleur ITS, which was called Trafficon at that time, they started investing in thermal technology. And they quickly found out that thermal has some unique benefits which contributes to a more performant automatic incident detection system. And also thermal technology can be used for new applications. So today, we want to present you the next generation for automatic incident detection. Today we want to present you the dual vision solution with thermal technology for effective fire management, visual technology for CCTV monitoring and smoke detection, and deep learning for enhanced automatic incident detection. All of this combined in a comprehensive and very cost-effective AID solution. So, what makes our solution so unique? Well, there are a lot of challenges inside tunnels when it comes to effective fire management. And the technology or the solution in place should be able to cope with all of these challenges. And a typical example, what you see here on the slide, is that some fires may be hidden. And depending of what is on fire, it can happen that it doesn't generate a lot of smoke. So it's in these cases that optical flame detectors or smoke point detectors will fail to pick up this fire. So a thermal camera is is detecting the object by its heat. So it will pick up this fire within its state of ignition. So it can perfectly cope with these challenges. Another challenge is the obscured vision. So if your tunnel is filled with smoke, your CCTV cameras are blinded and the operators don't see if people are trapped inside a tunnel. A thermal camera can see completely through the smoke. So it's in these situations that both optical and thermal technology can work together for a more effective fire management. With a visual camera, you can detect the smoke, and with a thermal camera, you can see through the smoke to see if people are trapped. This see-through smoke feature from thermal vision or thermal technology is unique in its kind, and it's a proven fact, and it's been used by thousands of firefighters worldwide. So, how come that thermal can see through the smoke? Well, the reason why thermal can see through the smoke is in fact because of the diameter of the smoke particles. The smoke particles, the diameter is covering the complete visible spectrum, and that is why a normal CCTV camera is completely blinded. But these smoke particles are much smaller than the working area of the thermal spectrum, and that is why thermal cameras are not, or thermal radiation can simply pass through smoke particles. So, another challenge for effective fire management inside tunnels is the windy environment. There's always a lot of wind inside a tunnel. And that's partly because of the fans which are in place. The fans, the responsibility of the fans, the ventilation, is to bring fresh air inside a tunnel, which is very good, of course, but it introduces quite some challenges for the conventional linear heat detector cables. These cables are installed normally at the ceiling of the tunnel, and they require the buildup of a heat from the fire. Now, in case there is a fire and there's a wind inside the tunnel, this heat is blown away from the fire. So this is blown away to another position inside the tunnel. This makes that the linear heat can suffer from delayed fire activation. And it also suffers from inaccurate fire location because the heat is traveling to another part inside the tunnel. So the linear heat detection system will send an inaccurate position towards the tunnel operators. So this delayed fire detection and inaccurate fire location is wrong information for a tunnel operator, and it can lead to wrong decision making. So as a thermal camera can detect a fire by its temperature within a few seconds, it can perfectly cope with these channels. And it doesn't matter if there's a wind inside a tunnel, and it also doesn't need any contact with the smoke particles. So it sounds that thermal technology can cope with any kind of challenge inside tunnels for fire management, but that's not completely true. There are also challenges for thermal energy. And the most common challenge we face are static hotspots. And static hotspots are very common and normal inside a tunnel environment. And these can come from, for example, rooftops from cars and trucks which were standing in the sun for a long time. Or, for example, exhaust pipes from trucks or cars passing by. Also, hot engines are having the same or the same temperature as a fire. So it is extremely important. Well, static hotspots are very normal in a tunnel environment. So the thermal camera should be equipped with an advanced early fire detection system. In some cases, of course, it's interesting to detect these hotspots, like if you have overheated tires or overheated engines. But it should not generate a fire event towards the tunnel operator. So the early fire detection from FLIR ITS is looking at every object in its field of view. And it's looking at the temperature. And if the temperature goes beyond a certain threshold, which you can set, it goes into another phase. And the next phase is it will check the behavior and the shape of the object. Is the behavior and the shape static? We can send a hotspot warning towards the operator. Once the hotspot warning is given, it will return to its beginning, and it will check again behavior and the shape. If this behavior and the shape is in the shape of a flame, we send a fire warning to the operator. In both cases, fire warning and hotspot warning, the operator should pay close attention to this situation. At that time, our algorithm is going into a next phase, and that is checking the growing volume of the flame. If there is a significant grow, then we will send a fire level 1 to the operator. And that means that he will have to take immediate action. So have the tunnels become safer? Well, in case you have smoke detection on visual, early fire detection on thermal, and the see-through smoke capabilities, we can definitely say yes to that question. So that brings me to the next topic. Not only effective fire management, but also deep learning can be used in advance with both visual and thermal technology. And without going too deep into deep learning, I want you to understand the basics of it. So deep learning is a machine learning algorithm, which is a subset of artificial intelligence. Deep learning is using big data, and big data is just a lot of data, a lot of images, and you use these images to train the model. And the model has its goal with an input image given to classify the image into a car, truck, bicycle, pedestrian, whatsoever. So if you give an image to the algorithm, to the model, it will tell you what it is seeing. So why is deep learning so important for the future automatic incident detection? Well, the big difference with conventional algorithms or other algorithms is that deep learning is increasing in performance once you're adding data. So if you have a little bit of data, your deep learning algorithm will not perform very well. But by adding data, you will in certain moments cross the limitations of the other algorithms or of conventional algorithms. And by adding more and more data, your deep learning will only increase in performance. So if you translate that to traffic applications, it means that you will have higher detection performance, reduction of false events, false positives, breaking limitations of other algorithms, and creation of new applications. So that is why it's so important that we introduce deep learning into the traffic market. So, but it is important that you know how you will use deep learning for automatic incident detection. And some companies are making the mistake of starting from scratch. Either they make a product with a little bit of data, so the eventual outcome will be that the product will not perform very well, or they take a data set which they can freely download from the internet. But these data sets will contain images which are not completely suited for the place where the product is installed. So FLIR ITS is not starting from scratch, but we are starting from our known technology. So we're building onto our existing algorithms. And we're only using deep learning there where it can really make a difference. So big data is very important for deep learning. The more data you have, the better your performance of your deep learning algorithm. But next to the big data, it's also the input image which has an influence on your detection or your performance. If your input image is very clear and it has a lot of details and it's very stable, your deep learning will also be very high performant and very stable in performance. If you apply deep learning to visual images, you come to a few challenges. And the first challenge is like the normal transition between day and night. When your deep learning algorithm is trained with images from daytime, and your camera becomes more darker and goes into nighttime, your performance will drop. So either you have a data set which covers all of these cases, or your product will suffer from performance. The same thing will happen if you, for example, take a data set which you can download from the internet and you apply it to a tunnel environment. These images from the internet, most of them are outside images in clear, bright sunlight. So if you apply them to a tunnel environment, the illumination inside a tunnel is completely different. So, so the performance will not be the same outdoor as indoor. Same thing with changing weather conditions, reflections from sun, from water. If you don't have all of these different kind of situations inside your data model, your product will suffer in performance. These were the challenges from using deep learning on visual, but visual also has its advantages. For example, you can use the color information. The color information can be used for creation of new applications, like distinguishing green from red cars. Also, visual can be used to classify objects. FLIR ITS has classifiers for cones, tires, and boxes. And at the same way, you can very easily add new classes. So if you have a client, or as a client, you have a special class you want to detect, the only thing we need is a lot of images from this class. We let the algorithm train on these images, and there you have a new class. That can be like a reflective jacket, rickshaws, taxis, maintenance vehicles, anything what you can think of. So it's very easy to just update the model. And by just doing a firmware upgrade, you will have that new class. So if you apply deep learning on thermal, there are also a few challenges. And one of those are called objects, like the cones, boxes, and tires, which we have seen in visual. These cones and boxes, they don't produce any heat, so they are much more difficult to recognize on thermal than on visual. Also, the lack of color information in thermal makes that some of the application you cannot do, like you cannot distinguish green from red cars. The big advantage of thermal is that your input image will be stable and very clear in any kind of changing environment. Thermal can perfectly cope with changing weather conditions, with rain, also the time of day. You cannot see on a thermal camera if it's daytime or nighttime. Also, you don't see any reflections from sun or from headlights from the cars. Fog or smoke. So the solution we present is using the benefits of both thermal and visual, and we combine it into one comprehensive AID solution. And this AID solution consists of 3 parts. The first part is the image creation, the dual image creation. We do that with our ITS series dual. The ITS series dual is a product which is especially designed for tunnel environments. It's very flat, so with that in mind, that in a tunnel environment you don't have a lot of space. And that sometimes a few centimeters does matter in a tunnel environment. Also, the housing of this camera is completely out of stainless steel, 316L. So it's perfect for very harsh environments like a tunnel or for bridges overseas, for example. The camera has best-in-class thermal full frame rate VGA cores, and you have a choice of 6 different cores, and it has a 10 times optical zoom. So designed for harsh environments, and it houses a dual vision library both on the thermal and on the visual core. Once the creation of the image is done, the thermal or the visual image is sent to our deep learning engine. And the deep learning engine contains a data set from both thermal and visual images. So the deep learning engine will do the detection validation, it will do object classification, and it's also very modular, which means that you can easily add custom classes. We also continuously improve our models, because we have a good relationship with our clients. We constantly can receive new data, new images. We let them annotate, and we just let the model train again with this new data. So once you do an upgrade, your system is automatically performing higher. So once this is done, we send the outcome to our flux traffic management system. The flux traffic management system is used by tunnel operator to visualize or to see the event. But we go beyond visualization. We also do network video recording. We have a lot of features for video management. And we always start from the idea that we want to increase the situational awareness for tunnel operators. So we want to make sure that he's more aware of the situation inside his tunnel. And one nice feature of that is that we are sending the event location from each kind of detection towards the flux, and we display it on a map. So he can perfectly see in this example for where the pedestrians are and how many pedestrians are inside his tunnel. So that concludes my presentation about dual vision for the use for effective fire management and deep learning for AID. I hope you find it interesting. We have a lot of more products and solutions in place, so I invite you to come and visit us at the booth, Hall 1, 335. So we still have some minutes left for questions and answers. So please, if you have some questions, I'm happy to answer them.
Can we have a round of applause, please? Thank you. Thank you, Erwin. Are there any questions? I have a microphone. Yes. Could you introduce yourself as well, please?
Good morning. My name is Stanislav Urgela from company Fimo. And I have a question to thing you mentioned, the threshold setting for warning. What are usual values for this threshold from point of view of temperature and maybe size?
The size of the fire, you mean? Well, the early fire detection will first check the temperature, independent of the size. So as you have seen on the video, even if you have a very, very small fire, even if you have a lighter, we can already detect the fire. So the temperature of the threshold can be set like you want it. You can also detect lower temperatures. And then after we have fire warning, then we start investigating if it has a behavior of a flame or if it's normal static. So it's actually, that is the way how we distinguish a normal hotspot from a real fire. And you really need to have that on the camera, otherwise it doesn't make sense. You have continuously, if there's like a traffic jam inside a tunnel, you see continuously hotspots from exhaust pipe and hot engines. So it's a lot of companies are saying we have early fire detection, but they often is just a hotspot detection. So that is really you should be very aware of that you really have an algorithm. The camera has an algorithm which really detects the fire and not only hotspots.
That's a unique selling point for you.
Indeed,
Yes.
yes.
Good, good. Any other questions? Yes. Can I reach over? Yeah.
Thank you.
Could you introduce yourself as well?
Yeah, Alberto Campanini, Custom Engineering. I have a question. So the database of the images for the deep learning is a common database or a specific for every single applications?
Thank you.
The database, we're not using the databases from the internet, because if you look at those images, they're never in the good position as we normally install our cameras. So we are in the industry for about 30 years. So you have a huge amount of images, not only visual but also thermal. So we use this data set for training our model. And this contains both images from tunnels and from outdoor. Yeah. Thank you.
There's one question I asked the previous presenter, and that is how does this fit into kind of this whole ecosystem that I would need as a road operator to get to me as just a driver along the road and get a pop-up, hey, watch out, there's a fire, or there's an ambulance have to pass by.
Yeah.
How does it fit?
So a lot of technologies have, well, each technology has its challenge and its benefits. So the combination of the technologies is really the future, and that's where we want to work to as well.
Yeah, yeah.
So it's not only that we also have radars on our stand.
Yeah.
So we are trying to combine all the benefits of all to provide a better or safer environment for the tunnels.
Okay. Yeah. Can you help me up? Because I'm gonna.
Yeah, sure.
Yeah, thank you. Otherwise, I have to walk all the way around. That's it. I have to close this off for now. You are available at stand 01.335.
Exactly.
I can imagine we don't know where that is. Can you show us the way?
Just the walk to the left here.
Left.
Yeah.
Okay.
And then about in the middle.
Okay. Somewhere in the middle on the left.
Next to the Unix
Okay.
booth.
Great. Great. Thank you for being here. Thank you for watching our online version of this. And of course, thank you for presenting.
Thank you.
Can I have a round of applause, please?
Thank you.
I'd just like to give an insight into our next presentation. That's about urban traffic management and then using access rights. So would I have an electric vehicle coming in, or do heavy goods vehicles need to stay out? So that's about access rights. If you're interested, please stay put. If not, have fun today. Enjoy. Have a good day.